Hey, I've spent some time and completed the data analysis functionality for ourProbes Angular client. So this video and the next video I'll have a look at the way I have implemented this. By the way, I'm using ngx-charts package to provide the graphing functionality. In this video I'll have a look at the data being used for ourProbes measurements and do a quick walkthrough of the data analysis overview functionality. And then I'll do a deeper dive of the overview visualization. In the next video, there'll be ourProbes26. I'll have a look at the trending visualizations and the data extract. I'll also show an example of using the data extract to bring data into Excel and into Power BI tool to do some custom data analysis and visualizations. So data analysis will be over two main sets of data. So there's the raw measurements, which we see here. So there's a record for every measurement that every probe that is run on every device creates, sometimes more than one measurement. So for example, we see a measurement here. It has a unique document ID, has the UMT time that measurement was created, the device is created on, the current probe's name, the probe ID, the type of measurement is, so this is a RTL, round trip latency measurement, and what the value is. As well as these raw measurements, there's measurement summaries, which we saw in ourProbes24 video, is created using a cron job. So let's have a look at an example of a typical measurement summary. So period tells you whether it's in this case, whether it's an hourly summary, so summary of all the measurements for that particular group of measurements over an hour, and also there's a daily summary that has a period of 2, and then all the information on that summary is the number of measurements that we use to create the summary record, the device ID, the mean, the name of the measurement, or the name of the probe that created the measurement, the various percentile figures. So remember that P50 is equivalent to a median, and otherwise it gives an idea of what the range of measurements are. The probe ID, the period, the standard deviation for that group of measurements that make up the summary. Again, the type of measurement, so BPS is bits per second, and the date timestamp, UMT time, for when that measurement summary was made. So just a note on the charting package that I'm using for this and the data analysis visualizations. I'm using a thing called ngx-charts. It's on GitHub, and there's a lot of good community support for this, as well as some good examples here. So things like heat maps, which I use, has this demo, also has a lot of good documentation about how to use it. The main reason I'm using ngx-charts is it's open source, it's on a MIT license, and like I said, when I look around the community, it's well supported, and the actual charts look pretty nice and are easy to work with in Angular. Let's have a quick overview of the data analysis functionality. You get to it from the menus, go to data analysis, which brings up the data analysis page, which has 3 tabs on it. One for the overview data analysis, one for trends, and one for extracts. So the overview, the purpose of that is just to give a quick overview of the current status of devices and probes. By default, it's going to show you the number of successful tests that have been done on the devices and the probes that are running on those devices over the last hour. Trends, like it says, shows the trends over a preset time range. So you can see here where we can get various trends for various time ranges and for the various metrics that were collected off the probes. This is using summary data, either hourly summary data or daily summary data. And finally we have the extract page, which shows or allows you to extract data for use in external programs. So for example, I just did an extract on hourly data, and I can download it and open it up in Excel, or else open it up in more fully functioned data analysis programs like Power BI, and I'll show an example of that, not in this video but in the video following this one. Actually I'll be covering trends and extract more in the next video. So for this video I'll just complete a look at overview, what it does and how it does it. Let's have a more detailed look at the overview functionality on data analysis, and then we can do a deep dive into the code. So as I said before, the overview chart is a heat chart, and the idea is it looks back at the last hour of measurements to give you various overviews over the status of probes running on devices. The default view is showing you successful tests, or the number of successful tests over the last hour. So you can see when you roll your mouse over it, tells you the number of successful tests. Tells me in this case that D03 device has had no successful test. And the idea of this is this just tells me whether tests are running on the devices, or whether certain probes are successfully finishing or not. So 0 would indicate that nothing's working. Number less than the maximum probably means that some of the tests are failing, and might be something I want to investigate for that probe or device, or combination of the two. As well as just doing the raw overview of the things like counts, I can look at more of the information being picked up by the measurements. And in this case, when I look at one of the metrics like round trip latency or bits per second, it just shows me what the last value collected in a measurement for that combination of device and probe is. So in this case I need to change it from showing counts to showing values, and in this case it is color coded to be a darker value, at least in the 2-color mode, for something that's got a higher value than a lighter value. So you see, the round trip latency coming in for doing tests against a target located in New Zealand is 228 milliseconds round trip, which is kind of normal for going from the US to New Zealand. And then going to my test location, so I've got that WAN emulator running on 92.198.129, and at the moment I've got it dialed in with a round trip latency setting of 20 milliseconds. So you see it's getting fairly reliable numbers coming back from both my probes running against devices running against that location. And another one, ourDARS, which is a Google hosted site. It's coming in at around 3 milliseconds round trip latency for that one, and 1.7 milliseconds round trip latency for that one, which looks about right. And you can do the same thing with BPS, or bits per second. You get the values. So going out to New Zealand, I'm seeing around 53 megabits per second. Going to ourDARS, getting some higher numbers, and going to the WAN emulator I've got running, I've got it dialed in at 500 kilobits per second, and these are measuring those numbers pretty much right on. But the only other thing to show in here is you have the ability to filter, just see probes running on a particular device, or the other way around, just see results for a certain probe running on all the devices. So this is a good way to compare what numbers I'm getting for a certain probe running from different locations. At the moment these are essentially running in the same location, so the differences in time here are just probably due to differences in network capabilities at the time each of these tests ran. And the only other user interface parameter here is to change the color scheme. So by default it's a 2-color scheme, so just going from light to dark. And for more complicated views, so I'll go back to no filter. So more complicated views, sometimes it's useful to have a wider range of colors so you can more easily differentiate sort of the real high values for middle of the pack values, which come in a different color. So let's go have a look at the code that's being used for this. Okay, looking at the code for this, so all three data analysis functions sit inside data analysis component, and all that simply does is hosts a material tab control, so an angular material tab control here with the three components inside it, the overview, the trends, and the extract. So we're looking at this daover component that provides all the overview functionality. So looking at the HTML for that, so sits inside a page container just to give it some preset margins. Inside that is an accordion control. Inside the accordion control is an expansion panel, and the title of that is created in a way that it shows you what the current parameters are being used when the expansion is either open or closed. So give you an idea of what's the time range, what's it's showing. When it becomes expanded, you see these various controls are then shown. So things like the filter to use. So a filter is a drop-down list of devices and probes that can be selected. The type of measurement to show, so bits per second, round trip latency, those sort of things. The measurement type, so remember I said that you can get measurements for both values and counts, so this is where that gets selected, whether you're looking at the values coming off the measurement records or the counts for all the measurement records within an hour, and the color scheme. And then underneath that, outside of the accordion, so this is always shown, at least when it's active, is ngx-charts, and it's a heat map chart here. It's got an ngif to show charts, so while I'm preparing the data, I turn off the chart until the data is ready, so nothing's happening on the chart until the data is ready to be shown. It's got the scheme selector, so remember I could select between a 2-color and a 5-color heat chart scheme, so that's where the particular scheme is selected based on the value that is currently active, and the rest of the values for the heat chart are here, and that's really just getting the values out of the TypeScript code in the background. And that's about it for the HTML, so after this we'll dive into the actual TypeScript code running behind this. Now let's look at the actual TypeScript code that makes up the component. I'm not going to go through the whole thing, but just go through some of the unique things I did. So I'm using things like keeping track of subscriptions, so I can pull things like the list of probes, a list of devices, and deal with them down in the code, so subscribing to observables I've made. Here you see where the color schemes are defined, color scheme 5, color scheme 2. Took a long time to choose the colors I like, but these seem to give me a good variety without being too jolting going between one value or the next. Let's go down here. So in it, the first thing it does is call the show overview chart, which is this this code here. I think one interesting thing is the use of the combine laters. So I've got 3 observables defined, so one for devices, one for list of probes, and one for measurements. Rather than dealing with them separately, I used the ngx operation of combine laters, so operator to subscribe and wait for all 3 of these requests to get a list of devices, probes, and measurements to come back. And here's the subscribe. It's been saved in our all data subscription variable, and And you see down here it's doing various things like building up the list of filters that I'm going to use, and also calls update chart here, and it passes on the devices, probes and measurements. So this is where it's building up the actual JSON structure to be passed over to the heat chart control, and the format for that is basically a list of each series, and then the values within the series need to be passed. So this code's doing the building of those things. And then you see down the end of after processing all that value, all that information, it flips the show chart value to true. I've got a bunch of on-change routines tied to the various drop-downs on the user interface to change values on the back end. And the one other thing I needed to make sure I did is when I'm leaving the page, to destroy the all data subscription, just to make sure it doesn't stay active and using memory even when you leave the page.